Hi, welcome to a walkthrough of SpinRite. I put this video together to give somebody who's unfamiliar with SpinRite some sense for the way it looks and how it operates. We start always by booting a system to DOS, which is easily done with a USB thumb drive that SpinRite is able to produce, or a CD-ROM, or however is best for you. After DOS boots, it presents that brief flash screen, and then it brings us into SpinRite's first couple of title pages. We'll skip past those. During the development of SpinRite, we discovered that some problems that were not actually hard drive related were being blamed on hard drives because people had machines with some defective RAM. So I decided to build a RAM test right into the front of SpinRite so that by default, anytime SpinRite is started, every time it's started, it'll be running this RAM test. There's no real requirement for how long it should run. My advice would be maybe to plan to let it run for an hour the first time you're using a given computer with SpinRite, just so that it has a chance to find any problems. But after you've done that once, there's really no need to continue doing it because you will have developed pretty good confidence in the quality of the RAM that you've got. The point is that this test will run forever. It doesn't end. It lets you run it as much as you want to. So you could run it overnight if you wanted to, just to absolutely be sure that the RAM was okay. If it hits a problem, the error counter in that upper right that you can see will increment, and the blue background switches to red. So it leaves no doubt that there is a problem. And you should absolutely not run SpinRite if any problems are detected in RAM, because data being transferred to and from the hard drive has to go through that RAM, and we want that to be reliable. In any event, as you can see from the timer in the upper left, we've been going here for 1 minute and 36 seconds, so I'm going to press enter to proceed to the drive discovery phase. We're now looking for various drives connected to this system, and I've got 3 drives: the USB drive that booted the system, and then 2 drives attached to the machine's ACHI ports. So they're both SATA drives. The first one is a 250 gig AddLink SATA SSD, as you can see. The second one is a 2 terabyte Seagate drive, which has had about, as you can see from runtime there, 77, a little more than 77, almost 7,800 hours of total use. That's all this is showing you, just the drives that SpinRite has found and their serial numbers. Pressing enter takes us to a screen where it's easy to choose which level you want to run SpinRite at. It has levels 1 through 5. 1 never writes anything. 2 reads unless it finds a problem, in which case it will perform data recovery for that problem. 3 is always reading and rewriting the data. 3 is what we would use and which we recommend using on an SSD probably once a year in order to read and refresh the data. I specifically chose that 250 gigabyte AddLink SSD because it's been in service, as you saw, for more than 1,000 hours, and the beginning of the drive, which is a characteristic we see in many SSDs, has slowed down a lot. Anyway, we'll get there in a second. I'm going to choose level 2 because I don't want to fix the SSD because it makes for a great demo. So punching 2 brings us to the main menu, offering us to select drives for level 2. We'll hold off on that for a second, using the down arrow to move to the View and Change Settings option. I then press enter. That takes us into the View and Change Settings page where I can set the level to whatever I want to. I'll just go in there for a second, and you can see that we're on level 2, and this explains what all the various levels do. We can turn logging on and off. We can decide what we want to do if we run out of log space. We can choose whether we want to log with full sentences or abbreviated phrases. Also, whether we want a screensaver to automatically activate. The screensaver is sort of built into SpinRite in a group of screens that we'll see. I normally have it off since I sometimes just want to watch what's going on, but other people like to set it for some length of time. Oh, and we can also choose if and when we want to include benchmarks automatically in the log. If we were to choose that, we have a choice of never doing them, benchmarking before automatically, after running SpinRite on a drive automatically, or both before and after. As I said, I'm going to leave it set to never because we're going to be doing it actually right now. So the next option is performing drive benchmarks. So here's the 3 drives that we saw earlier on the first Discovering Drives and Benchmarks screen. I'm going to, while the first drive is highlighted, I press enter in order to run benchmarks on that AddLink SATA SSD drive. Random sector timing is not very interesting on an SSD because, of course, being solid state, they're all pretty quick. But we can see the front of this drive is not behaving very well compared to what the middle of the drive looks like, and especially the end of the drive, even a little bit faster still. This surprised us when we began working on SpinRite because many of SpinRite's early testers were reporting something like this. We would expect a solid-state drive to have uniform performance across the entire surface. That's the way they come out of the factory, but after you've stored data on them that has not been rewritten for a long time, it turns out drives have a difficult time reading that data back. One of the big benefits of using SpinRite 6.1 is that it's able to refresh SSDs in order to restore their factory performance. Let's move down to the 2 terabyte Seagate drive and run a benchmark on it. We expect to see much different random sector time. It's jumping around, but typically about 15 milliseconds, which is good. And on a spinning drive, the front of the drive is the fastest because the cylinders are the longest out on the outer periphery. The middle is somewhat slower, and because they're these days squeezing every bit of data that they're able to, they go down to very small circumference tracks on the innermost areas of the drive. So this is not unusual. The end of the drive is actually less than half as fast as the front of the drive, just due to the fact that the tracks are longer out there. We're not going to bother doing a benchmark of the 16 gigabit drive. Okay, so I hit escape to come back to the main menu, go up to the top item, and we're going to now do our drive selection. Here again are the same 3 drives over on the left. Over on the right hand side, we see information about whichever drive is selected over on the left hand side. We can see drive information about the drive's hardware, and whatever it's reporting through the self-analysis and reporting technology, you know, the smart system. Going back to drive information, now going down to the 2 terabyte Seagate drive, we see its information that it's connected to a SATA 3 port, which is running at 6 gigabits per second. That is the interface is, not the drive itself. Certainly Seagate drives are not able to, well, spinning drives are not able to saturate a SATA 3 port at this point. Total sector count, total byte count, and as we can see, it is more than 2 terabytes of space. We're also able to transfer at 32768 sectors per block, which is to say 16 megabits or megabytes at a time. And the measured speed that SpinRite found during its first little benchmark. Again, hardware information for that drive. And this drive, the Seagate, is showing us much more information about the smart status. We can almost always we get the temperature of the drive shown, but here we're seeing how many error correction events there have been, the drive's own margin of 71, that is its own self-reported health margin, and other data. Okay, so let's actually run SpinRite. We'll go back here, we'll select this drive and the second drive, so we're selecting both of the drives in the system, press enter to proceed. At this point, it's verifying that we're about to run operations on level 2, which is for recovering unreadable data. It does offer us the ability to press tab if we wanted to edit the current starting and finishing locations. Doing that shows us the screen looks like this, where we're able to edit. Instead of going from 0 to 100% on each drive, we could set it to some other starting point. And we'll see, because we're not going to go through all of the first drive, that when we interrupt a drive's operation, we are told exactly where we were stopping to 4 significant places after the decimal point, which allows us to come back to this screen and enter those if we want to resume at the place that we had previously ended. Okay, so we come back out here and press enter to begin running SpinRite. This is the SSD. This screen, and we call it the graphic status display, is your sort of typical big grid that allows you to see any consequences of anything that SpinRite may have found on the drive. Down below, the total number of megabytes that we'll be running. Since it's 255 megabytes. Did you notice how it just sped up there? That's because the front of the drive has problems. It's not really, you can see it's not really running at a consistent pace. Let's switch to the next screen to see that. This is the raw data snapshot, or real-time activity screen, where we can actually see the data that SpinRite is processing. And you'll notice you'll see it like sometimes pause a little bit. It shouldn't be doing that. That means because the data has not been written in a long time, it's having a difficult time, you can see it slowing down there, having a difficult time recovering that data. No errors are reported. It's not having, it's not like complaining too much. It's just slowing down because it's been a long time since that data's been written. Whoa, look at that. Really slow. Yeah. Now, if I were running level 3 on this drive, which would be rewriting the data that was read, this would be fixed, and that drive would come back up to full speed. The next screen over is the detailed technical log. The screens that we saw earlier are recorded here, and as we'll see, after I interrupt this drive, we get a bunch of other information that is also being written to a text file on the boot drive, so you're able to retain that information forever. Next screen over is the Smart System Monitor. Again, this SSD isn't publishing much smart information. I've never seen this change when I've been experimenting with this drive. Next screen is the Dynastat Data Recovery, which if there was a problem that was found, we would jump automatically to this screen and you'd see a lot of information, a lot of things happening here. We're able to change SpinRite's operating level at any time we want to, so we don't have to be stuck on level 2. Again, if I went to level 3, we would start doing repair on that SSD. And then the final screen is number 7. Actually, I forgot to show you something. If I press space on any of these screens, this gives us a screen selection menu, which allows us to step through the various screens as they're happening. And the 7th screen is the screen blanker that just looks like this. No real need to use it on today's LCD screens, but if an error were to be found while this blanking screen was up, again, the background turns red, just to let you know that you're not seeing it because you're looking at the screen blanker, but SpinRite encountered some problems. And if you hit the right arrow to go back to the beginning, again, you're able to step through the screens using the menu or the left and right arrows. Most people just use the left and right arrows to move through the screens. Okay, so we've come this far. I'm going to hit escape to interrupt operation on this first drive, and we want to cancel this drive only. So I'm going to select that option. Now it tells me which drive I'm on and that we are at exactly 9.8406% of the drive. That allows us we're able to put that in to that earlier screen if we want to resume later at exactly where we told SpinRite to interrupt. So we hit escape to acknowledge this. Now, because I selected 2 drives, we're going to immediately start on the second drive, which was that 2 terabyte Seagate spinner. And there we are. As you can see down below, we're now at just shy of 2 2 million megabytes, which is 2 terabytes, and this is moving along in a much better clip. Let's go to the next screen. Yeah, this drive, obviously it's been in use. You can see it's got data on it that we see flashing by. But it's at a uniform pace, no problems reading, no hesitations, no pauses. This thing's moving right through. I'm going to hit the right arrow again. Here is the detailed technical log at this point. The SSD card is what we did first, right? The SSD drive. So now we scroll down. We see the event of the interruption logged in the event log, that same 9.8405% of the drive's operation. Here is the graphic status display as we left it from that first drive. The final sector event counts, no problems were found at any point. Here is the end of run smart system status, which looks the way it did, and the final drive temperature, and it shows that we're concluding. Then, since we did a second drive in the same pass, we move right into this Seagate 2 terabyte drive. Now I'm going to hit the right arrow again to look at the smart data. This drive is publishing a lot more smart data. We can see, you'll see that the raw data, the actual error corrected count at the top line on the right, it changes periodically because error correction is occurring. That's not unusual on modern drives. It's typical because they're relying much more on error correction than traditional drives, where it was really the exception rather than the rule. If we were to allow this drive to run long enough, we would see that it's getting a little concerned about the amount of error correction being done. Right now, the current and max are showing at 75 for both, but it can get pushed down by SpinRite actually doing the work. It's not clear whether that's a problem. To really determine that, you'd have to get a bunch of drives that were the same make and model and run SpinRite over all of them, and then by doing comparison among the same make and model drive, you could weed out the weak ones. Some people do that. They'll buy a couple extra drives when they're wanting to set up a big multi-drive RAID. They'll run SpinRite on each of those drives individually before it's in the RAID, and then find the two that are the weakest and return them, because why not? You can. Here's Dynastat again, still not doing anything useful because we're not recovering any data, able to change the level, and back to our screen blanker again. So anyway, that's the way SpinRite looks as it's running. Oh, we've gotten out of the area where there's any data on the drive, and so we're just seeing mostly empty sectors at this point. Okay, hit escape to exit, and now we're going to come to the main menu. We're going to go to the main menu. This tells us that we got 2.43% of the way into that drive. Back at the main menu. If we wanted to, we could come down and look at the detailed technical log. That's useful if you forget to browse through it and you'd like to browse through it in color. The text file's not in color, so this is a little bit prettier to see it this way. And the other feature is a built-in FAQ that answers the most frequently asked questions about SpinRite. The same information can be found at grc.com. We're able to scroll through the FAQ item by item, or we're able to jump to whatever we want. For example, there's a command line options reference in D. So I'll hit D, which takes us to the command line options screen, where we can see various ways you can start SpinRite from the command line option in order to cause its behavior to be different in various ways. So anyway, that's SpinRite. Hope you enjoyed the walkthrough.